Hello students, here we have a problem which is related to the box, spring, energy conservation and so on. So if you have such a problem, then how can we solve such a problem? So suppose we have a spring which has a K constant, and then it's compressed to certain length, which is X, and we are holding it here. Let's call it 1. You are holding it there, and then you released it. When you released it, it will move a certain distance before it will stop, right? So before moving, it will have initial velocity, and when it's moved at a certain distance, it will have a final velocity. And we are here including a friction, okay? Kinetic friction. Now we know the kinetic friction is opposed to the motion, so it will be pointing to the left. Now, we can solve such a problem by using the energy conservation. Energy initial is equal to the energy final, okay? And plus energy lost. Or in other words, we call it work done by friction, okay? Energy lost by friction. So how can we solve it? So what do we have here? First of all, we have kinetic energy initial plus potential energy of the spring initial is equal to kinetic energy final plus potential energy spring of the final plus work done by friction, okay? Now let's look at the kinetic energy initial and final. Now when we compress and we are holding it, we have initial velocity which is equal to 0, so therefore we can say that kinetic energy initial is equal to 0. Then when we compress to certain lengths, to certain x, and we are holding it, that means we have our kx initial, okay, it's already compressed, which we have, or in other words, we can say it's equal to kx, which is equal to, now when we released it, the all kinetic energy, all the potential energy of the spring will be converted to the another energy, right? Or we can say that kinetic spring potential energy, kx final, will be equal to 0 because it will come to the initial stage. Plus, do we have kinetic energy final? Kinetic energy final is also equal to 0 because it will move certain distance and then it will stop. So therefore final velocity is equal to 0, so we can also eliminate the kinetic energy final. What about work done by friction? Work done by friction is equal to the kinetic friction multiplied to the distance, right? So therefore finally we can get the formula where we have kx is equal, sorry, here we have kx squared over 2. Sorry guys, I forget it because it's energy. So kx squared over 2 is equal to the kinetic friction times a distance that is moved it. So then if you continue, if we continue, then we can have kx squared over 2 is equal, the kinetic friction is equal mu k times mass of the box times g times a d. Now we have a formula where you can find what is unknown, okay? Suppose sometime you can find what is how much it's compressed, or sometimes you can find what is the coefficient of kinetic friction, or sometimes you can find what is the distance that box is moved before it stops.